So let's review how to solve literal equations. All right. Now, whenever you're working with a literal equation, they're always going to tell you which letter they want you to solve for. So in this example here, they want us to get the letter C by itself. So what you need to do is you need to solve this equation for C, right, using the algebra skills that you guys have learned when it comes to solving equations. Okay? So if I need to get C by itself, the first thing I realize is if C is inside this square root, I need to get rid of this square root because C is inside this square root. So to cancel this square root, I am going to square both sides, right? So we're going to get d squared on the left side is equal to, now this exponent and this square root will cancel each other out. So we end up with 4a squared plus b squared divided by c squared, right? Now, we need to get c by itself. Now, if c is in the denominator right here, we need to get it out of the denominator spot. So that means I'm going to need to get rid of this right here. So I'm going to multiply by c squared on the right side. And then when I do that, I also have to multiply by c squared on the left side. Now on the right side, this c squared cancels, which is what we want, because we don't want c to be in the denominator. And then where's the c now? The c is on the left side and is not in the denominator. Okay? So we have c squared times d squared on the left is equal to 4a squared plus b squared, right? Now, next step, we want to get the c by itself, so we're going to get rid of this d squared. Now, if c squared is multiplying with d squared, in order to cancel out this d squared, we will have to divide by d squared on both sides. So these divide out, we end up with c squared is equal to 4a squared plus b squared divided by d squared. And then the last step, we need to get rid of this exponent. So what we're going to do is we're going to square root, because the exponent and the square root cancels each other. So whatever you do on one side, you have to do on the other side. So it's very important for you to remember that first of all, okay, so the square root and the exponent cancel here, so we get c is equal to. Now, when we do this step where we square root both sides, you have to remember that you need to have a plus minus over here now. So we're going to have plus minus the square root of 4a squared plus b squared divided by d squared. Okay? Alright, so let's take a look at this second example now. So for this little equation, we need to solve for the letter k. Okay? So first of all, I noticed that there's a k on the left side of the equal sign and a k on the right side. Okay? So whenever the letter that you're trying to solve for, if it's on the left side and the right side of the equal sign, you want to get those terms together on the same side. It doesn't matter on the left or the right, but we need to get the k's on the same side of the equal sign. Okay? So if I need to get the k's on the same side, so I can add p, right, to both sides to get rid of this. So I will end up with 6 ck divided by 5 is equal to, and then this will give me 3d minus mk plus p. Now remember, I'm trying to get the k's on the same side. So what I'm doing is I'm going to add mk to the right side here. I'll add mk to the left side. So I'm going to end up with 6 ck plus mk is equal to, and then we'll get 3d plus p, right? So the reason why you want to get the k's, right, on the same side is because you should recognize that, well, this has a k, this also has a k. So what I can do is I can factor out a k. I could take a k out from both of these, right? It's kind of like the reverse of distributing, right? So the GCF here is k. So if I take that out, if I take out a k from here and here, I'm going to have k parentheses 6 times c plus m, right? So it's kind of like the reverse of distributing, okay? Is equal to 3d plus p. Now, if I was trying to get k by itself, right, so I have k times this whole thing inside this parentheses, So if I want to cancel out this thing inside the parentheses, I should divide by this whole term, 6c plus m, right? Divide by 6c plus m. So these divide out, and I'm going to get k by itself, which is what I want. 3d plus p divided by 6c plus m. Okay? All right, so let's take a look at this example here. So in this example, we're also solving for k. So we're trying to get the k by itself. Now we notice k is inside this radical, right? So k is inside this radical. Now this problem is a little bit different because you notice only the numerator, right, is inside the radical. The 2a is not inside the radical, right? So before I square both sides to get rid of this radical, let's get rid of this 2a. So I'm going to multiply by 2a on both sides. So that way, on the left side, it'll be gone, and I get the radical by itself. So I'm going to get the square root. I'm going to get the square root, negative b squared minus 4 kfc is equal to, and then I end up with 6a squared times b. Now that the square root is by itself, now you want to square it, okay? So typically, I think it's a good idea to get the square root by itself first, and then you square both sides, right? So I square both sides now. I square this. So the square root and this exponent cancel each other. We're left over with negative b squared minus 4 kfc is equal to 36 a to the 4th b squared. Now remember, we're trying to get the k by itself, right? So I'm gonna get rid of this negative b squared. So I'll add b squared to both sides. So I'll add b squared to both sides. So those will cancel each other out. I end up with negative 4 kfc is equal to 36 a to the 4th b squared plus b squared. Now on the left here, I'm trying to get k by itself. So all of these terms, right, all of these terms are multiplying with each other. So if I just divide by negative 4 fc on both sides, that'll get the k by itself for me, right? So these divide out, the f, the c, so the k is by itself, which is what I want. And then on the right side, I'm just going to be left over with 36 a to the 4th b squared plus b squared divided by negative 4 fc. Okay? All right, so let's take a look at this example right here. Okay? So for this example, we need to get x by itself. All right? So the first thing you should recognize is I see x on both the left side and the right side of the equal sign. Okay? So similar to the other example we did earlier, if you have x on the left side and the right side here, you need to get them on the same side of the equal sign first. Okay? So it doesn't matter if you get the x's on the left or on the right, but you need to get them on the same side of the equal sign. So in order to do that, I'll minus xu on the right, I minus xu on the left. So that's going to give me 4x square root r minus xu plus t over v is equal to, so this cancels out, square root b. Okay? Now we need to get the x's, right? We only want these terms by themselves. So let's get rid of this t over v. So let's minus t over v here to both sides, right? Because we want to get the terms with the x's by themselves. So now on the left side, we get 4x square root r minus xu is equal to square root b minus t over v. Okay? So now that we have the x's on the same side of the equal sign, right, and there's nothing else around them, what we can do is we can do that step where we take out the GCF. Since both of these have an x, I'm going to take out an x. So we have parentheses, and what am I left over with? 4 all right, square root r minus u, right, inside the parentheses, is equal to square root b minus t over v. Okay. Now we want to get the x by itself, so all we need to do now is just divide by this whole term, 4 times root r minus u, divide by 4 times root r minus u, right? So we get x is equal to square root b minus t over v divided by 4 square root r minus u. Okay? Alright, so let's take a look at this last example here. So in this example, okay, we need to get the x by itself. Okay? So you always want to check first, okay, where are the x's? So I only see one x in this example. Okay? So there's only one x in this example. So the first thing you always want to do is check, you know, okay, whatever letter you want to get by itself, all right, where is it inside, where is it in the equation? Okay? And if there's more than one or not. All right, so I notice this x is inside this square root. So what that means is eventually I need to get rid of this square root, right? But remember, you don't want to get rid of this square root until it's by itself. So the first thing we want to do is we need to somehow cancel out this b and cancel out this c, right? So that we get the square root by itself. And then we can square both sides, okay? So the first step for this problem, what I would do is, well, let's say I just minus b on both sides. So I minus b on both sides. So that'll get rid of this. So I get negative square root 5xy over 3 is equal to 3y plus 1 minus b, right? And then the next step, well, I want to get rid of this 3 because I want the radical by itself. But there's also this negative, right? So what I'm going to do is I'm going to multiply both sides by a negative 3, right? So multiply both sides here by negative 3. So the reason I do that is the 3's are going to cancel out on the left, and this negative times negative will make this positive, right? Because I want this radical to be positive. So square root 5xy on the left is equal to, and then on the right, I'll get negative 9y minus 3 plus 3b, right? Now the next step, right? So now that the square root is by itself, now I want to square both sides, okay? So you always want to make sure the square root is by itself, then you square both sides to get rid of this square root, okay? So when I square both sides, I square this, so this and this is going to cancel. I get 5xy is equal to, now this right here, you don't need to multiply this out. You can kind of just keep it negative 9y minus 3 plus 3b. So don't worry about squaring this and multiplying all this out. That's not necessary when you're doing these solving literal equations problem. And then the last step, we want to divide by xy to get, divide by 5y to get the x by itself. We divide by 5y on both sides because we want the x to be by itself. So then that's going to give us x is equal to, so these divide out, negative 9y minus 3 plus 3b squared divided by 5y. Okay?